welcome back. It's good to see you again. We're going to take this section in two parts. The product rule will be the first part. We'll call that 2.4a, and we'll do 2.4b as the quotient rule. They're very similar, and I want to avoid any confusion that we can possibly have between the two. There will be some confusion. You have to work hard on that to keep these two separate, but it's not really a big deal. I gave you a hint the other day too. Okay, let's go with the product rule, part 1. We're going to find derivatives of functions using that product rule. And here we go. Now, check here. There we go. Just had to check and make sure the pen's working. So, pen, oh, there it is. Okay, I was looking at the wrong place, sorry. Alright, so here's the definition of the product rule. And the one I gave you the other day looked like this. First of all, we've got a function, and that function is composed, good word there, of two other functions. Now this is slightly different, but this is the one I used on the board the other day, so this is what I'll stick with. So we've got a function that's composed of two others with multiplication, and we want the derivative of that composed function, and we'll just keep it simple with respect to x. And all you need to do is take each one of those functions and multiply it times the derivative of the other function. So let's start with g of x times h prime of x, the derivative of h of x, plus, then we'll just reverse the roles, g prime of x times h of x. You could also write this as df dx equals g times dh dx plus dg dx times h. Whichever one of those really hits you the best, stick with that, or you could use what I put on the board. If you want the derivative of f with respect to x, g times h prime plus g prime h. There's a simple version. You might like to remember it like that. Nice and simple. So let's get into some examples. We've got an f of x here, and it's composed of the product of two simpler functions. Now we could do this just by multiplying and then taking the derivative, but this is to get you started using the product rule. So to get the derivative of that, which will be f prime of x, or if you want to, you can call it dy dx, equals. Now this is what I do. You can do it a little bit differently if you like. I write it like this. I write the first function, that's 1 over x plus 1, times, and then the second function with a prime up there, meaning we'll take the derivative of that, plus, and now just swap the two. 1 over x plus 1 prime, or derivative, times the x minus 1 without the prime, and then work it from there. So let's go. First of all, we want to rewrite this first one. Or do we need to? Maybe not. In a lot of cases, you might have to. So we'll leave this 1 over x plus 1. Now what we're going to do in this whole section right here is just take the derivatives that we need to take. So for the second function, let's take the derivative of that. Well, how about that? It's just 1. Nice, right? Plus. Now we'll have to take the derivative of this one. I'm going to sneak up here for a second because I might want to write that as 8x to the negative 1 plus 1. Take the derivative of that. And what do I have? Bring that negative 1 out front. I've got a minus x and subtract 1 from the negative 1. That's a negative 2. Take the derivative of 1. That's 0. So we're finished with that derivative. And then times x minus 1 alone. Let's see what we've got. Okay, first of all, over here we've got 1 over x plus 1. That's pretty simple. Plus. What do we have over here? I might want to quickly rewrite this one. This is negative 1 over x squared. And I'm going to multiply that times this x minus 1. So minus 1 over x squared will be minus x over x squared. We'll work this out later. That's this times the first term. Then we'll take it times the second term, which will give us plus 1 over x squared. See, double check here. Make sure I've got that right. First one times this. One of those x's will cancel out. We'll have the minus. And minus times the minus, we'll have a plus. Good. And the x squared in the bottom. I think we're ready to keep on going. 1 over x plus 1 plus. Now we can reduce this to minus 1 over x and then 1 over x squared. So what do we have for the derivative of f, our composite function? Well, if we look at these two, they're exact opposites, addition-wise. So those two give us just 0, and I'm left with 1 plus 1 over x squared. And there's our derivative. And there we go. They did it a slight bit different, but it's equivalent. And notice this is the same as 1 plus 1 over x squared. So we're good. So now you have two differentiation rules. You've got the constant multiple rule and the product rule. And the constant multiple rule, remember, is when one of the factors is a constant. So we had two functions actually being multiplied together. And if you accidentally use the product rule, it's going to come out the same. Because remember, the derivative of c is 0 because it's a constant. So you've got those two rules. So there's a constant multiple rule, and you've got the product rule to go with it. Now we're going to compare those two rules. This is mostly so that you see the difference between them and you don't mistake one for the other. So let's take the derivatives of each of these functions. So let's take part A over here. And we want to find y prime or dy dx or f prime of x. Now, if you like the way I did it in the last one, there's 2x and x squared plus 3x. I want the derivative of that one. Remember, with the product rule, of a plus between those two. That's very important because the quotient rule is different. Plus, and then we're going to swap the roles of those two. We'll take the derivative of 2x this time, and we'll leave the x squared plus 3x alone in the second one. Now let's see what we've got. Y prime equals 2x is 2x, nothing to do there. We need to take the derivative inside this one, so we'll have 2x plus 3. And then over here, we'll take the derivative of 2x, that's just 2, and leave this alone, x squared plus 3x. What's that give us? Let's see. Let's expand on this. 2x times 2x is 4x squared. 2x times 3 is 6x. And I'll just give a separation here for you. 2 times x squared is 2x squared. Plus 2 times 3x is 6x. All right. I think we're about ready to finish this up. So what do we have? We have 6x squared plus 12x. And there's my derivative of y, also called dy dx. Now let's take the second one, b. It looks as though I have less room here, so I have to be more efficient with my writing. So next one, y prime equals. Now the first term I've got is a 2. I can use the constant multiple rule, just leave that 2 out of the way. And I'm going to take the derivative of x squared plus 3x. So y prime equals, leave that 2 alone, take the derivative of what's inside of a 2x plus 3. Distribute, and y prime equals 4x plus 6. Quite different, right? 4x plus 6 for this one, and 6x squared plus 12x for this one. All we did was just add a factor of 2x. Move along here. And with that short example, that's all you really need for the product rule. The last thing to mention is that we can extend this, and this really looks ugly. We've got 3 functions being multiplied together instead of just 2, and this is how you could work that. That's not how I would generally work that. The way I would do it would be, I would look at it this way. Take the derivative of, and then think of this as f of x times g of x. I'll take the derivative of that, and then I'll work with h of x later. So looking at it this way, we can take the derivative dx. This part right here, we'll take the derivative of f of x g of x times just h of x. So we need braces around that. So we'll take the derivative of this written this way, or you can put g of x and h of x together. It doesn't make any difference really, but work it using the product rule. And you'll use this alone times the derivative of that, and then the derivative of this times this alone. That's the way you can do it. It's the easiest way. Okay, that's it for the product rule. A little bit short, but very sweet. Now remember, get this one down straight. Do 3 or 4, maybe 5 exercises using the product rule, and then come back and pick up the quotient rule, and you'll be set. See you in class. Bye.